Welcome students. Welcome to the lecture number 12 of Mysql revision tour. Okay. So today we are going to discuss some topics regarding the Mysql. Now you can see that today we are going to discuss about some relational operators, right? And the first one is the Cartesian product. So what is basically a Cartesian product? For explaining you about it, first I have created two tables. The first table name is course and the other table name is student. Okay, and you can see that in the course table I have taken three fields: COU ID for storing the course ID, then CNAME for storing the name of the course, and duration for storing the duration of the course. Okay, and then the another table student is created, in which roll number, name, address and this COU ID, course ID, these four fields are present. And in this case I have created course ID of this table as a foreign key of this table. And how I can and how I will do that, you can see this line that foreign key COU ID references course table course ID. By this statement, this course ID field of student table get connected with the course ID field of the course table. Okay, so here this course ID is basically the primary key, right? But when it is connected to this course ID becomes the foreign key. Okay, I have told you about this concept in the earlier videos also. So now we have created two tables, one is the course and other one is the student, right? Now, so in course table I have entered these records, that 101 BCA duration is 3 years, 102 BBA duration is 3 years, MBA 2 years, BTech 4 years, and along with that I entered some records in the student table also, right? So these are the records of the course table and these are the records of the student table. Now what is basically a Cartesian product? First of all, it is denoted by the symbol X in the relational algebra. This is basically the symbol of cross. Okay, and remember one thing, we are talking about the relational algebra operations. Okay, as we know that we have performed many queries in SQL, but there is one more thing that is called as relational algebra, and in relational algebra the Cartesian product is shown by cross symbol. Okay, and this Cartesian product is also known as cross product. Okay, so remember one thing while noting down it, write down the another name of it, that is Cartesian product is also known as the cross product. Okay, this is also known as the cross product, right? So the first thing is that in relational algebra, Cartesian product or cross product is represented by the symbol of cross. And the second important point is that it produces a new relation. Relation basically refers to the table. Okay, as we have discussed in the database terminology, that relation word is basically used for the table. So what work is performed by this Cartesian product? This Cartesian product operation produce a new table, okay, in which the degree is equal to the sum of degree of both the tables. So obviously we perform Cartesian product in two tables, and the result which is obtained by the Cartesian product of these two tables have degree equal to the sum of degree of both the tables. And what is the degree? Basically, degree is basically the total number of attributes in both the tables. Okay, and cardinality of the resultant table is equal to the product of the cardinality of both the tables, right? So you have seen that we have used two tables, right? One is the course table and other one is the student table, right? So when we perform Cartesian product on both these tables, we get a new table in which the number of columns is equal to the total number of columns of both the table, is equal to the sum of the total number of columns of both the tables, and the total number of rows is equal to the product of total number of rows of both the table. Let me show you. For obtaining the Cartesian product, we have to write the command select star from, then we will write the name of both the tables. So when we specify this command, then we get this kind of result. Okay, so this is basically the Cartesian product of both the tables. Now here you can see that the first record, that is all the records of the course table get combined with all the records, first record of the student table. You can see over here all the records of the course table like 101, 102, 103, 104, all these records are combined with the first record of the student table, and then they are they are combined with the 101 to 104, they are combined with the second record of that table, then all the records are again combined with the third record of the table, then again all records are combined with the fourth record of the table, and then all records are combined with the all records of the student, fifth record of the student table. So first of all, as I told you that this is basically a resultant table. Okay, this is basically the resultant table. Okay, and this, then the degree means the number of columns in this table is how many? 1, this is 1, this is 2, this is 3, 4, 5, 6 and 7, and you can see that these first three columns belong to the course table and these rest of the columns belong to the student table. So the total number of columns is basically the sum of both the columns. So total columns are 7, 3 from the first table and 4 from the student table. So the total number of columns shown in this result is 7. Okay, now after that you can see the number of records. There are 4 records over here. Okay, 4 records here, 4, 8, 4, 12, 16 and 20. Okay, no. Okay, so now you can see that in the course table there are 4 records, right? And in the student table there are 5 students entries now. So in the student table there are 5 records. So as I told you, the total number of records of both tables are multiplied. So in the resultant table we have 20 records with us. You can see that over here there are 20 records, right? So basically this is the purpose of the Cartesian product. I think you may be confused that why we are performing this Cartesian product. What is the purpose? What is the use of this Cartesian product? Actually this Cartesian product is basically used for performing the join operation. The join operation we will discuss in the later on, because it is the last topic of our lecture, and in that thing I will clarify, you will see that what is the use of this Cartesian product. Okay, so before joining the performing the join operation, system will first do the Cartesian product operation internally, and then the join operation is performed on that. Okay, so you will get the clear idea about this Cartesian product when we perform the join operations. So now let's move to the next relational operation, that is union operation. Okay, so we have discussed one operation, that is the Cartesian product. Now we are discussing about the next operation, that is union operation. So suppose we have 2 tables with us. The first table is named as IP. I have created a table named as IP and another table named as eco. So suppose there is an institute in which IP and eco classes are going on. Okay, suppose in IP we have these 3 students with us, and in eco also there are 3 students. So suppose the institute decided to give some gift to their students on the occasion of New Year. Okay, So now they have to place order. So they basically they want to see that how many students are there in their institute. But suppose if they consider that there are three students over here and 3 students over here, if they see that there are 6 students, so basically they are mistaken. Why? Because there is a student named as Sakshi whose admission number is 120. She is also a student of IP class as well as she is also a student of the Eco class. So it means a single student is basically attending both the classes. So that's why he is counted twice, which ultimately give us the wrong figure, right? So union operation, what will the union operation will do? Union operation will combine the records of both the tables in such a way that common records appears only once. So let me give you a brief description of it. The union operation in relational algebra, union operation is represented by this U symbol. Okay, in relational algebra, union operation is represented by this U symbol, and it produces a new relation. New relation means it produces a new table, okay, in which all the tuples means rows, all the tuples from both the relation are included, but common tuple appears only once. Okay, but common tuple, how many times it appears? It appears only once. So in this operation you have to remember one thing: the number of attribute must be same of both the tables. Okay, it can't be performed if the one table has 3 columns and other table has 5 columns or other than 3 columns, then they will not be used in the union operation. The number of attributes and their type must be same. So you can see that I have performed this select star from IP. Okay, so basically this command will give me all the records of the IP students, and when I write this command select star from eco, then this will give me the result of all eco students. And when I perform union between these two results, I will get the record of these students. Okay, in here you can see that the Sakshi record is shown only once. Okay, it is not considered twice, or over here it is written 5 rows in the set. It means only 5 records are shown. So you can understand that when you perform union operation, then what will happen? Basically the union operation combine the data of both the tables, but the common records will appear only once, right? So after that, the next operation is basically intersection operation. So what is the purpose of this intersection operation? First of all, this intersection operation is denoted by a reverse U symbol. Okay, so this is the notation for the intersection operation in relational algebra. Now this intersection operation will produce a new relation. Okay, it will produce a new table, right, in which only common tuples appears. It means that record which is common in both the table will only be shown as a result of the intersection operation. So it means when we perform intersection operation on any two tables, then records, then the common record from both the table will be shown as a result of intersection operation. So in this operation also the number and types of attributes must be same. Only then the intersection can be performed. No? Now suppose we have a table of IP and we have a table of eco with us, and when intersection operation is performed on these two tables, that is IP intersection eco, then we get the result of only Sakshi, because Sakshi record is common in both the tables, and the intersection will give us only the common record. Okay, now the next operation is minus operation. Okay, so first let me give you some brief introduction about it. So first of all, the minus operation is denoted by the symbol of minus in the relational algebra. Okay, so in case of relational algebra, the minus operation is denoted by the symbol of subtraction. Now it produces a new relation. Obviously it produces a new table as a result, in which only those tuples from the first table is shown. It means the records from the first table is only shown to the user, which is not present in the second table. Okay, so it will show the record of first table except those records which are present in the second table. So let me give you the example of this, and also in this operation the number and type of attribute must be same. Okay, the number and type of attributes must be same. Now suppose we have these two records, one is the IP table with us and other one is the echo table with us. Okay, now suppose if I perform this operation IP minus echo, so it will show me the records of only IP students, and in the result it will exclude, or we can say that it will ignore the records of those students which are already studying in echo also. So it will show me the records of only those students who are studying only IP, not echo. So we will get the answer as this, Karthik and Nandini, because Karthik and Nandini, they are studying only IP, they are not learning echo, but basically Sakshi is also in the echo batch also. So what we can say that in this case IP minus echo means all the records of the IP table and the records which is common, which is present in the echo table, is removed from the IP table. So the Sakshi record is present in the echo table, that's why it is removed from the IP table, and the result is shown in like this. But if we perform echo minus IP, then the result of echo students will be shown to me, but in that result the record of those students get removed which is also present in the IP table also. So it will show me only the records of those students who are in echo. Okay, so you can see that Sumit and Sonali are the two students who study only echo. So echo minus IP means the records of IP students removed from the echo table, and then the result will be, and then the remaining records will be shown. IP minus echo, the records of echo students is removed from the IP table, and then the remaining student result is shown to the user. Okay, so this is basically the minus operation of the relational algebra, right? So today I am finishing this lecture right now. Okay, so just go through all these operations, and one more important thing that I have to tell you, one of the important fact is that this MySQL does not support intersection and minus operators. Okay, I have shown you the result, but this intersect and minus operations are used in the relational algebra term case. Okay, they are not supported in MySQL. You can run the Cartesian product in MySQL, you can see the result of union in MySQL, but when you want to run intersect and minus operation in MySQL, you will not see the result. Okay, because these operators are not supported in MySQL. They are supported in other version of the DBMS software which use the SQL language, but intersect and minus operators are not supported in the MySQL software. But we are talking about the relational algebra operators, that's why we have discussed it. Okay, so that's all for today lecture. Thank you very much and have a nice day.